Welcome back to the most bingeable math content on the YouTubes. We're in lesson 4 of integrated 3. We're going to do a little bit of division today with some polynomials that are already factored out, some that still need to be factored out. Some quick vocab is here. The setup that you might see as we push into problem 1 is going to say that you have a divisor, g of x, which is really just x plus 7. And you have this division roof. You have a dividend of f of x, which is factored out, x plus 7, 2x minus 3. And we're thinking out what quotient, when multiplied with this divisor of x plus 7, matches this x plus 7 multiplying with 2x minus 3. Take a moment, really think on this. What times x plus 7 gets you all of this? Hopefully you're saying 2x minus 3. We can even check this in a long division type format. X plus 7 multiplying with this. I'm not going to FOIL it out because it would get a little gross. But if I have these two subtract from each other, don't they all cancel? Doesn't it leave me a remainder of 0? Sure does. So we're able to now say that our quotient is going to be parentheses 2x minus 3. That's our final answer. There's no remainder. And this is really a precursor to when we covered long division of polynomials in lesson 5. So they're pushing you to do something like this. Feel free to try problem 2. It's going to be very similar. I'll tell you right now, your answer is going to be 5x plus 7. But I'm curious, can you show me the work as to why that is? Here, your answer is going to be part of f of x, but not the full thing, because g of x is pretty close to matching f of x. Some of these you may feel the inclination to factor, but I don't know if you really have to. This one's going to be awfully similar. And you know what? Maybe take a moment to try problem 4 out, and I'll have the work here in a second. So pause the video, try problem 4a, see what you get. So I hope that you were asking yourself, what times 5x minus 3, this 5x minus 3, gets us to 5x minus 3 multiplying with x squared minus 11x minus 9. It might seem silly to ask these questions, but I think it does help build up your sense of the problem and what you're really trying to hunt down. If you set it up like this and compare and contrast, you're really missing this x squared minus 11x minus 9, which you could also say is h of x. And that's the answer that we need. Capiche? Sound good? Hopefully you got that one. 5, you're going to have to do a little bit of factoring. I hope you don't mind if I take you through factoring just this polynomial. We're going to need to do a little bit of work here. I need to multiply a times c. So 2 multiplying with 3 means that we have a product of 6 that adds up to our b term of negative 5. And again, we're doing this factoring because our a term does not equal 1. So that's why we're putting in a little bit more work to figure out factors of 6 that add up to negative 5. It's going to be negative 2, negative 3. So now I can hop back here and say that although this is 2x squared minus 5x plus 3, I can also rewrite it as 2x minus 2x squared minus 2x minus 3x plus 3. And so from here, I don't know how integrated 2 taught you how to go through this, but you can now use factoring by grouping, where you start out with the first half and think, all right, what's the greatest common factor of 2x squared minus 2x? What do you think? What you say? Hopefully you're saying 2x. If you factor that out, that'll leave you with x minus 1. If we do this correctly, the other binomial over here should match exactly and be x minus 1. But now you have to think out what times x gets you negative 3x. So definitely a 3, but what kind of 3? Hopefully you're saying negative. So now we can really say that this is, when factored, 2x minus 3 multiplying with x minus 1. So you can now hop back, do a similar setup to what we've been doing. Again, I factored this because you're going to see that previously x minus 1 wasn't there under the hood, but now when it's factored, it's 5x minus 6, 2x minus 3, and x minus 1. Capiche? Make sense? So now thinking what times x minus 1 gets you this set of binomials being multiplied. There's definitely 5x minus 6 in the mix. Definitely 2x minus 3 in the mix. And we don't need to multiply with this because we already have it. So we set this all up. The step might be extra. If you know what you're doing, you probably don't even really need to write it out like this, but I still think it's a good checkpoint to make sure that each term gets canceled. Your remainder is 0 when these all subtract from each other. So your final answer here is 5x minus 6, 2x minus 3. Probably one of the more challenging problems in the ready. But again, this whole section is just getting you ready for division of polynomials, long division in particular. Maybe take a moment, pause the video, try out what you can in the multiplying set. A lot of these are going to be simple. If you need to use box method, if that's your jam, do it. Someone in the other class said that they preferred the area method, which I thought was interesting, but this is another approach. A times A gets you A squared. A times B gets you just A times B. A times B, B squared. I think of this as like a little funnel where I'm funneling together some like terms. So I have x squared to kick it off. This is two versions of A times B. So let's add on 2AB. Finally add on B squared. Capiche? Sound good? Again, I used box method. Maybe you have another method that works for you. Run it if that's your jam. 7 something you could do. 8 something you can do. 11's one. Yeah, I should do that one. Why not? I'm gonna set up another box, another chill 2x2. Doesn't really matter which binomial goes on each side as long as you're consistent with the side of each term. Put 2x minus 7 up top, x squared plus 2 on the sides, 2x multiplying with x squared, it's 2x cubed, minus 7x squared, quattro x, minus 14. You might think, yeah, there's that funnel. I can combine these two terms, right? But can you? Really? No. This is x squared. This is just an x term. Lose the 14. Not much you can really do once this is simplified, so just leave your answer as is. So previously I said that this little diagonal funnel is something to look into, but it only works if the terms are common. We have been introduced to this in the classwork. We have the triangle here we can use. Although this is going to the 5th power, we can easily sketch out what that's going to look like. We start with 1. 1 plus 4 will get you this 5. 4 plus 6 gets you this 10. 6 plus 4 gets you another 10. 4 and 1 will get you 5. Finally conclude with 1. And so although this isn't sketched out for x plus 1 to the 5th power, think about what we said during the classwork. As we move towards the right, x loses an exponent, but a gains an exponent. So we can really treat this as if it's going to be 1x to the 5th power plus 5a x to the 4th plus 10 a squared x to the third plus 10 a cubed x squared, a little bit more, you got this, plus 5 a to the fourth, just times x, and then finally just a to the fifth. So take a moment, try this out for this problem. Again, try without the actual foiling or box method. Try to use the triangle. Challenge yourself. Try this out. Again, keeping in mind that a equals 1. Pause the video, try this out. Did you get this as your answer? Again, a is 1, so there's not too much interesting with a squared or cubed or to the fourth, but your answer would be something like this. Let's try one more. Let's make it a negative term. Why not? We know from the Pascal triangle that this should be 1, 3, 3, 1, where it's definitely going to be our first term being cubed. We're then adding on 3a x squared plus 3 a squared x plus a cubed. All right. So a in this case, interestingly enough, is negative y. So that does change up things a little bit. Maybe try this one out on your own, see what you get. We'll talk about it. If you were foiling around, you might end up with this and say it's multiplying with this. But if you're using the triangle, you'll eventually get something of this nature. Key ingredient is that a, remember, we said is negative y. So that means that here it becomes a negative term. Here it stays as is, positive because it's being squared. Down here, we claim it's subtracting y cubed. Capiche? Makes sense? Hope that one helps. What else is here for you? You get some nice throwbacks of graphing. Your parent function, x squared. Maybe take a moment. Do you remember all of the, I don't know if they call them anchor points, but do you remember a lot of good points from x squared? Take a moment, sketch out 5. Alrighty, hopefully you sketched out these 5 for the basic parent function x squared. When I look at this, I think that it's shifting all of these points up 2 units. So sketch a little XY plane. I know there's one below this, but I'm in a rush. I got other fish to fry. So plus 2, kicking everything up a notch. And this goes up to now 3 points above 2, or sorry, 3 points above 3. So this is actually negative 2, 6. And this point over here is going to be 2, 6. And this is also 1, 3, negative 1, 3. You get it? Capiche? Again, you graph these for a bit. I know I could have used the graph below, but whatever, it's in a pinch. And if you've even watched this much of the video, you probably know what you're doing anyway. But that's that one. This is going to be what kind of function? Exponential with a shift up of 2. Maybe a quick sketch of 2 to the x power is going to help you. Y-intercept is 1. When x is 1, the outcome is 2. When x is 2, the outcome is 4. And then you have these little fractions that kick you back down a notch. So this is really just a quick sketch of 2 to the x power. So this is now just kicking it up. You guessed it, 2 units. Do I really have to show you all this? Are you even watching? Do you have me muted? I would be curious to find that out. All right, let's kick these all up a notch. You can say that you have a imaginary boundary line called an asymptote where y equals 2. It's going to keep kicking back from there. And what's this do? Goes up 2, right? You need points for this? I'll hand them over if you need them. Did I do this one right? No, that ain't right. Is it? 2 squared? Oh yeah, that is right. How about that? If you need some points, ask and you shall receive. You could say that when x is -2, that it's going to be, what is it? 2 1/4. Then -1, 2 1/2. Again, this is a, what do they call this again? A mixed fraction? Whole number, fraction, mixed fraction. 0 and 3, 1 and 4, 2 and 6, so on and so forth. If you did this without consulting a calculator, I'm pleased, I'm impressed. This is 2 to the x, this is 2 to the x plus 2. Capiche? Not on. This thing does not change. That's crazy. You have a vertex at 2, 0. You have an A coefficient of 3. I'm going to leave this one to you. Plug in some points, but you'll definitely want a more thinned out graph. So a thinner graph than 2x squared and also x squared. So make that thing move up pretty quickly. Mod on. Your lowest point on this absolute value is 1, -2. It's going to kick out from there. Just as a quick sketch. I think that should be good enough. Again, make it more like an absolute value versus a quadratic. Dude, integrated just does so much. A is 1/2. Your vertex is 1, -2. You've done these problems so much. Integrated, so sick. I'm going to leave this here for you. Shout out, Jack. If you have any questions, reach out. Take care. Brush your hair.